Okay, here you go. Page 27. Your notes from yesterday. Calculator out, ready to go, because you're going to need it definitely today. Before I introduce the end of yesterday's notes, I just want to take you back to the unit circle real quick up here. All right, again, unit circle always has a radius length of 1. All I want you guys to do here is help me set up Pythagorean theorem. I got a right triangle up here. Can you help me set up Pythagorean theorem here for a triangle on the unit circle? Where are the two legs? What do I label as the two legs? So I can go x squared plus y squared equals 1 squared, or 1, right? Everyone agree with that? No big deal. Okay, now that we're on the unit circle, what do we say the x-coordinate represents? On the unit circle, this is day 3 now, so on the unit circle, what does the x-coordinate represent? Cosine. So instead of x, I can put in cosine squared. And what coordinate was what represented y? Sine. So I can write in sine squared equals 1. Grab your calculator right now for me, please. Grab your calculators. Marissa, pick an acute angle for me, please. Pick an acute angle for me. 30. All right, and make sure you're in degree mode, by the way. Make sure you're in degree mode or this will not work. Okay, here's what I want you to do. In parentheses, do cosine 30. Okay, square it. Plus, now do sine 30 and square it. And what are we all getting? 1. Yep. Okay, and that would have worked for any angle, acute angle Marissa would have picked. Okay, the cosine squared and the sine squared of an angle always equal 1. All right, that's called the Pythagorean identity, and we're going to use it right now. Okay, on the next page, we're going to use it. Here we go. You have an angle. We're calling that alpha, correct? We're in what quadrant? Which quadrant? Second quadrant. Remember that at the end of the problem. All right, remember we're in the second quadrant at the end. If you know sine is equal to 3/5, use the Pythagorean identity to determine cosine. Okay, here it is up top for you again. Cosine squared plus sine squared equals 1. Which value do I already know? Here we go, going to you guys now. Big suspense here. Let's go. 10. What value do I already know here? What value is given to me? Which represents what? Okay, sine represents sine, right? Okay, so now I'm going to take it, go into my equation, cosine squared plus sine squared. I'm going to leave cosine alpha squared. I'm solving for that. I'm not plugging it in. Plus, what was my value for sine again, Art? So all I'm going to do, not sine 3/5, just 3/5 squared equals, what's it all equal to? 1, and I'm solving this now. Okay? So that's why we needed our calculator. Cosine alpha squared plus, I need 3/5 squared from somebody. 1, 3/5 squared, Olivia. Got it, 9/25 equals 1. Okay, what do I have to do with that 9/25? Because I got to get cosine all by itself. So I got to move 9/25. How? How am I going to move it? Here goes your algebra skills. 19, how am I moving it? Good job. You owe me 1. 7, how am I moving it? Everyone go ahead, subtract it over. 1 minus 9/25. Let me know what that is as a fraction. When you have it as a fraction, let me know. 12, let me know. What do you have it as a fraction? So 16 over 25. Still not by itself. Still not by itself. One last step to get it by itself. 20, one last step. Take the square root of both sides. So cosine alpha equals, go ahead everyone, take the square root of 16 over 25. Should come out to be a nice little fraction for you. And you end up with 3. So cosine equal to 4 over 5. Here we go. We're going to have this awkward staring match until somebody speaks up. Let's go, Alex. Come on. Be there. Be there. What's that? Why can't this be positive? Sorry. Why can't this be positive? Because I told you to remember what at the beginning of the problem. What quadrant are we in, Alex? Second. And guys, from yesterday, ASTC, what did we learn about cosine in the second quadrant? It's negative, so you got to remember that. So it's not a positive 4/5, it is negative. What? We're in the second quadrant. All right? It's the little things here that are going to catch us. I know it. Are you okay on that one? Because one doesn't make you great here. We okay on that one? Next one. Okay, where's my angle now? Where's theta in this one? Which quadrant? First. So at the end of the problem, I know automatically my answer is going to be what? Positive. Got to be. I don't even have to worry about it at the end. Positive. Cosine is 1/3. Determine the value of sine. All right, here we go. So 1/3 all squared plus sine theta all squared, all equal to? Everyone all right on how we're using this? We good? All right, 1/3 squared. Here we go. As a fraction, please. As a fraction, not a decimal. 1/3 squared, 12. When you're ready. 1/9 plus sine squared theta equals 1. Your next move. 3. Go right ahead. Subtract the 1/9 for me. Sine squared. What do you got for me, Ben? Yep. Next step. 9. 20. Again, yes. Ooh, bad news on this one. Let me know how you go. Let me know how this goes. Let me know how this goes. Yeah, let me know how this goes. What's the problem, kids? Decimal. And can you turn it back into a fraction? Oh, that stinks, huh? Even though the directions clearly said simplest radical form. All right, so we're going to have to take care of this algebraically. Yes, Ashley? Well, I'm getting there. Okay, so now your calculator can't handle it. We need to do it by hand now. So yes, everyone see how we took a big square root of 8/9? That's the same as saying square root of 8 over square root of 9. Same thing. All right, same thing. Everyone all right? Okay, square root of 9. So what do I get on the bottom? 3. And you're not leaving it square root of 8 because you're better than that. You're in big boy, big girl math now. All right, square root of 8 is not going to cut it. Break it down for me right now. Break it down. Four and 2, right? Square root of 4, square root of 2. Four and 2. What's the square root of 4? 2, square root of 2. So that's what, oh, positive or negative? Why positive? And what do you know about anything in the first quadrant? It's always positive, all. All right? So there's 2 of those to practice later on page 29. All right, so later on when I give you the time, you can go to page 29 and practice 2 more on your own. All good. All right, I didn't want to do that on top of everything else I did yesterday, so it's good we finished it now. Questions from you guys? Wednesday, remember unit test? All right, so here's where we are right now. We've been working consistently on the unit circle. X coordinate was cosine, Y coordinate was sine. What was this deal with ASTC, you guys that were here yesterday? How's this work? All students take classes. What's the A mean in the first? All or what? Positive. What's this S mean? Sine is only positive. Everything else? Negative. T, tangent is only positive, meaning sine and cosine are what in the third? Negative. And C4, cosine only positive in the fourth. All right, and then I have our Pythagorean one that we just went over. Any questions from you guys? Because it's just more practice of this today, making sure we got this nailed down. We good? All right, well, let's find out. All right, we're ready. We're ready. Okay, here we go. A little warm up here. I got 6 sine x. What's the value of f of 60? Ooh, your function notation from last year. Where am I going to plug that 60 in for? F of 60. Where am I going to plug it in for? In for x. So I am asking you guys to find what? 6 times the sine of 60. Okay? Don't even think about touching the calculator. I get it. It's multiple choice. You'll get a decimal. Figure out which one matches. I know you can do that. I don't want to do it that way. 60. Where are we on the unit circle? 60. That's been a huge one. Where are we on the unit circle? What's the coordinate? 9. What's the coordinate on the unit circle? Got it. Thank you. 14. What's the coordinate on the unit circle? $60 on the unit circle. I'm doing sine. Which of the 2 coordinates do I want? I'm doing sine right now, everyone. Which one do I want? 3. Which one do I want? Y coordinate. Sine always equals y. So it's going to be 6 times. What's the y coordinate, Ben? So 6 times radical 3 over 2. Can we handle that? Algebraically, can we handle that? Because notice none of your answers are decimals. Anybody know how to multiply those two? Top times top, bottom times bottom. So top times top, what do we get? Yeah, I don't want a decimal. So 6 radical 3 over bottom times bottom. 2. Go one extra step. What do you have? I didn't call on number 2, but I just said over 2. But you could finish this if you want. 6. All I'm looking for is 6 over 2. That's all I needed. 3 radical 3. Yeah, way to be on your toes. Okay. Yeah, I know you were. Questions? Anything? Okay, I'm not going to do number 2 is another Pythagorean theorem one. We already went over 2. All right, and I don't want to spend more and more time going over another one. Okay, even though I do want to mention this. Eliminate 2 of the answers for me without even doing that Pythagorean theorem I just showed you. Eliminate 2 of the answers for me. See how far we've come here. Confidently eliminate 2 of the answers if I'm finding sine right now. Brett, you're going to eliminate something? No. Okay. Lily? Why am I going to eliminate? Explain to the class here. Why am I eliminating 3 and 4 even though I'm not even going to do Pythag? Sine in the third quadrant, negative. That's how powerful that is. Okay, so we can come back to this one later on, but I don't want to do Pythag right now. Okay. All right, here we are. Put it in all together. Exact form? Anybody? A little quick. No darn decimals, yes. It's useless plugging sine of 570 in your calculator. Maybe until the end if you want to check, but that's it. So here we go, 570. What's your first move? Yeah, make it smaller. How? Subtract it. Go. Make it 570 smaller. What is it? When it's smaller, go ahead, 19. 210. So sine of 210. Next, where are you? 210. Where are you in what quadrant? 5, where are you? Third, sine. Tell me something, Mary. It's going to be negative. So I know my final answer has to be negative. Even if you want to rewrite it with a negative sign to remind yourself, go ahead. But in your mind, you're saying your answer is negative. How do I make 210 smaller? Find its what? Find the reference angle. 210, reference angle. And at this point in the year, it should be 30, 60, or 45. If you get something else, something went wrong. Because those are the only 3 we know how to deal with. So what's the reference angle for 210? 15? 30? Now you go to your unit circle. 30 degrees on the unit circle, pick off the correct coordinate because it's sine. All I want now, final answer. That's it. Final answer. You went to 30 degrees on the unit circle. I don't need to keep asking people what it is or what coordinate you picked off. 3? I'm just wanting final answer. I know that's what's at 30. Now you pick off the correct coordinate and tell me what my final answer is. You're doing sine. Which coordinate should I pick off for sine? So negative 1/2. And look, if you plug that in your calculator, could you get away with it? Yeah. Because go ahead, do sine of 570 in your calculator. What are you going to get? Negative 0.5 probably, right? Okay, so you could get away with that one and just write negative 1/2. I don't blame you. All right, but if it's a decimal, that's going to be a problem. Skip over to C. Cosine of 3 pi over 2. Anybody? Pi over 2. 90 times 3. 90 times 3. So this is the same as cosine of 270. Guys, where's 270? It's a quadrantal angle on the line, right? What do I always have you do if it's on the line? No unit circle stuff. Just plug it in your calculator. If it's on the line, just plug it in your calculator. And you end up with, there you go, 0. All right? We all good? I'll save 135 for another time to review. Guys, all good? Questions? Because I'm done with the unit circle now. I got to go to something else. I'm done. Ashley? Nope. What we discussed in class, you should only memorize the 30-degree one, right? Why just the 30-degree? Flip it and you get the 60. And what's 45? That's an easy one. radical 2 over 2, radical 2 over 2. They're always the same. And then from there, if you do any higher than 60, you just find the reference angle. All right? And just remember what quadrant you're in. Okay, I'm not concerned with this. Okay, let's go right to number 4. Now you're not on the unit circle anymore. You're not on the unit circle, unfortunately. Okay? I'll show you why that matters right now. So go ahead, find graph point 34 on the graph. 3, 4. And you're going to draw the terminal side in and an angle in standard position. So draw the terminal side in. Everyone see the angle you formed in standard position? Put a theta there for that angle. Put a theta there for me. There's your angle right there. Okay. Probably should make it a little smaller. Okay. There's your angle. All right. So we have 3 jobs. 3 jobs right now. Find sine, find cosine, find the actual angle measure. Now maybe some of you are like, oh, this is easy. Sine is what coordinate? It's the y, so sine should equal 4. We're not on what anymore, though? We're not on the unit circle anymore. Okay, so that does not apply unless we're on the unit circle. So everyone agree, I just can't take 4 for sine and 3 for cosine and I'm done. Okay, I am not on the unit circle. So what are we going to do here? We're going to go back to your boy SOHCAHTOA. Or girl, sorry. All right. We're going to make a right triangle out of this. Everyone see the point 3, 4, draw a vertical line straight down. And you have created what type of triangle? What type of triangle have I formed? A right triangle. Can you find the 2 legs length? The length of the 2 legs. Go ahead, I'll ask somebody. Uh, 14. What are the 2 lengths of the legs? 4, yep, going up, and 3 going to the right. Can you find the hypotenuse for me? The length of the hypotenuse? If you don't know that these numbers off the top of your head, we could always do what theorem? Pythag, yep. So you could do 3 squared plus 4 squared equals c squared. Or if you know what the 3, 4 blank is, then you're good to go too. But you can always use Pythag. So when you're ready, what is that hypotenuse length? Here you go. 3, what is it? It is 5, yep. Okay, ready? Sine. Let's do sine first. We're working in a right triangle, so I want to use SOHCAHTOA. What side over what side? How do I find sine? 13. You got it. Here we go. Opposite over hypotenuse. So what side is opposite theta? What side is the hypotenuse? 1. Here's your angle, right, Olivia? Oh, yeah. So go ahead now. 4. Over hypotenuse? 5. Got it. 4 over 5. Cosine. How do you find cosine, kids? 20. 3 adjacent over hypotenuse. So now that would be 3 over 5. I got it. Yep. Ooh, and then here comes the tricky part. It said find sine, find cosine, and then find the actual angle measure. What quad am I in? 1, so I at least know it's got to be between 0 and 90. All right, so I'm going to need your help trying to find this angle. Anything you want to try to throw out there, how to find the angle. And it has everything to do with this bad boy right here, the calculator. Nope. What? Has something to do with on here.
Inverse.
Oh, hi, Grace. How you been? Good to see you. Yes, anytime you want to find an angle, I'm going to use the inverse button. The inverse of what? You got two choices. You want to do sine or cosine? Your call. Cosine? Sure. All right, so everybody right now to find theta, we're going to do the inverse of cosine, but plug in what into our calculator when it asks for it? What do we find cosine to be? 3/5. All right, I'll do it with you. Here we go. Inverse cosine 3/5. So that angle, what does it ask me? Nearest degree in the directions? Okay, so what do you got? 53 degrees. Yep. And if you chose to do sine instead, all right, you'd still get 53 degrees. Okay? Where this becomes a little nuts, and I think maybe on the next one, is what if we're not in the first quadrant and I need to find the angle? But we'll deal with that. All good? Anything from you guys? Yep, you're hungry for more. Maybe you haven't had lunch yet. Here you go. Oh, yes, now we're not in the first quadrant. 6, -5. Let's do the same thing. 6, -5. Okay, so theta now is that angle in the fourth quadrant. Okay, that angle in the fourth quadrant. Do you see the right triangle we could make? Just draw a line up from 6, -5. And just like we did for the last one, can you label 2 of the sides? Find the lengths of 2 of the sides. What's the horizontal side up top here? How long is it? 6, yeah, you went over 6 on the x, right? And down 5. Down 5. Down 5. Why do you do that, Art? It's so ridiculous. -5. Okay, I do not, even I don't know what 6, 5 something on the hypotenuse, so I'm going to do Pythag. So 6 squared plus -5 squared equals c squared. Please keep in mind, kids, the hypotenuse is never negative. Okay, it's always positive. So let's see what somebody gets for the hypotenuse length here. Maddie, comment down back there, please. 15. I do not know numbers, so who has 15?
Oh, me.
Just what's the 11? Okay, here's the problem. Anytime you square a negative, your calculator says it's negative 25. That's because you got to put it in parentheses. 61. Square root of 61? Because you're going to take the square root, correct? All right, so just leave it square root of 61. We're all good? Okay, so there's your hypotenuse, square root of 61. Answer some questions for me now. Sine theta. Opposite over hypotenuse. Again, you want to go from your reference angle. All right, go from the reference angle. Go from the reference angle. So what's opposite and hypotenuse going from the reference angle? 4? Here's my reference angle, Sarah. Here we go, right here, where it's opposite. Okay, hypotenuse. Yep. Hey, and doesn't that make sense? Guys, what quadrant are we in? 4, and we just found sine. What should we have known about it? Yeah, there it is. It's negative. But now we still have to have some self-respect. No radical in the denominator. Self-respect. Good. So how do I get rid of the radical in the denominator? Multiply top and bottom by square root of 61. So finally here, the sine is equal to negative 5 radical 61 over 61. Radical times itself is the number underneath. All right, how about cosine? Predictions, positive or negative? Positive. It better be. Better be. 20, adjacent over hypotenuse. What do you have for me? Yep. And same thing, have some self-respect. No radicals in the denominator. So you end up with 6 square root of 61 over 61. And then what's the final thing we need to do? Find the angle. This angle should be somewhere in between what and what? We're in what quadrant? 4. So it should be between what and what? 270 and 360. Here we go. What are we using to find the angle? Okay, let's pick cosine or sine. Are we going cosine again? Okay. So cosine, inverse of cosine, but now plug in what in your calculator? 6 square root of 61 over 61, right? And you can do that in a fraction template. And I don't think you're going to like your answer here, but we'll see. Wait a second, that's not in quadrant 4. You're correct, it's not. Anybody know what that 39.8 is? It's the reference angle. Okay, that's your angle right there, 39.8. Can you use that to get to the angle in the fourth quadrant now? If your reference angle is 39.8 and you are in the fourth quadrant, can you actually find the angle in the fourth quadrant? 39.8, what would have been the angle in the fourth quadrant then? And I want to know how you got it. So 39.8 is your reference angle. You're in the fourth quadrant. 10, little help. How you getting it? 360 minus that 39.8. And rounded to the nearest degree, Art, my angle's what? 320 degrees, yep. Okay. Questions from you guys, because I'm going to have you do one on your own now. Oh, boy. Okay, I'm going to have you try one on your own right now. I'll get you started, and then I'll let you finish. Okay? So what quadrant am I in here on this next one? I'm in quadrant 3. And here's a little something different. I give you what cosine is equal to. So can we make up a right triangle in the third quadrant? Now, I know, hey, I get it. Some of you may have, you're like, oh, boy, that one. We get all crazy here. How do I know what the triangles are going to look like in each quadrant? Ready? The bow tie. The bow tie. See the 4 triangles? Okay, great talk. Sorry, I even showed you a little something here to help you out. Sorry, I never have. In each quadrant, do you see the triangle in each quadrant? Yes? Okay, all right, I can't keep this up. What quadrant are we in? Third. So I want this triangle right here. All right. What's cosine equal to again? Yep. But as far as SOHCAHTOA goes, because I need to put the 8 and the 17 somewhere on this triangle. Cosine is adjacent over hypotenuse. So the -8 should go adjacent, right? So I'm going to put the -8 right there because that's adjacent to my angle when I'm in the third quadrant. And what's your hypotenuse? $17. Jokes. And I'm going to let you guys take it from here. Find the missing side using what? Pythagorean Theorem, and then try to find sine and the angle in the third quadrant. Okay? We'll see how you do. I'll come around, just take a peek over your shoulder.